And I'm back. And what we're going to talk about here today is alternators. Now, here's an alternator. Every car and truck out there has got an alternator in it. Okay, I'm just going to give you some basics on how they work and some of the particulars of the light that comes on your dash if your alternator fails. Okay, so here's basically the old and new style of driving an alternator. This was a V-belt, and this is a serpentine belt. This is like a flat belt that you'll see in most modern cars. Older cars had a V-belt, okay? Sometimes you'll still see V-belts around, but the end result is the same. They just turn the alternator, okay? A lot of people think the alternator is just to charge the battery, but it actually, in a modern vehicle, the engine runs off the alternator. All the electrics run from the alternator when the vehicle's running, and it has the secondary purpose of charging the battery. On a gasoline engine, it's firing the spark plugs, it's running electronics, it's powering lights, horn, radio, fan, all these things. So, and if the battery wasn't replenished as you're using it, it's just going to go dead, and that's going to be it. It's finite, right? It's a direct current. It's just going to come out of the battery. Power is going to come out of the battery until it's depleted, and then you don't have any battery. And everyone knows if your battery dies in the car, you stop. That's it. You're done. Okay, so without getting too deep into it, I'm just going to show you an alternator that I've taken apart, some of the internals, and I'm going to explain to you with a drawing how it works. The alternator is spun by a belt from the engine, okay? And the rotating part in an alternator is called the rotor, okay? The stationary part of an alternator is called a stator, which is the armature, okay? That just consists of 3 separate windings interlaced with each other, and it comes down to these 3 connections right here. Okay, so just the very basics of how an alternator works. They're belt driven by the engine. It spins this component. This is a rotor, okay? And there's copper windings down in here. Now there's a small electrical current delivered from the battery, an excitation current they call it, that comes into the rotor, and it creates a magnetic field, okay, around a copper wire. When you wind copper around a nail, for example, and you apply a voltage to it, there's a magnetic field that is formed around that nail. It's the same thing here. So mechanical energy with an excitation current in the rotor that turns, creates a magnetic field, and that magnetic field interacts with these copper windings, and a current is induced in these windings, and then they're taken out here, and they come through what they call a diode trio. Now, an alternator generates alternating current. These are poles on the rotor here. You see these here? North, south, north, south, north, south, north, south. It's the same thing. You get back to the electromagnet created with a nail and copper wire wrapped around it. So as it turns, the poles reverse themselves. North, south, north, south, north, south, north, south. And it's the same thing. The current that comes out of here is north, south, north, south, north, south, north, south. So it's alternating current. So alternating current, we've all seen sine waves like this. But basically, if you just take a center line on that, it'll come from a negative value. They go to a maximum positive, to a maximum negative, to a maximum positive, to a maximum negative, like that continually. Alternating current isn't what we need in a car, though. We need direct current because we're running a 12-volt DC battery. So how do we do that? So they have a rectifier here, and the rectifier, it rectifies alternating current. All it does is it changes alternating current from this waveform just to flat line. So direct current is just flat, straight out, okay? An alternator only puts out power when there's a demand for it, and there's a way that it does that. And that is through the voltage regulator. Okay. Voltage regulator has a couple of terminals on here. We're going to explain what they do in a second. We've got a drawing here I'm going to show you. Okay, and the voltage regulator, how that works is it senses how much voltage is in the system, and if it drops, like a heavy load, if you're running a lot of accessories and stuff like that, what will happen is the voltage regulator will increase the excitation current that goes to the field in the rotor, and it'll increase the output of the alternator, how much power is generated from it. Now, on the other hand, if the voltage is high and the battery's at a full charge, you don't have any load coming off your engine, it's very minimal loads, what will happen in that case is the voltage regulator will reduce the excitation current going to the field on the rotor, and a correspondingly lower output from the alternator will result. Okay. So how does the field get energized? Where does that excitation current come from? It comes through the brushes. Okay, there's brushes right here. I'll show you. They're held in by spring. See? And see they move on a spring like that. And they run against these slip rings here, like that. Okay, so the output from your alternator is actually a little higher than 12 volts. It's about 14.5. And that's just what it puts out, and it'll charge a 12-volt battery to about 12.7 for a full charge. Okay, it's just, but it's all called a 12-volt system. Okay, just so you know. If you ever put a multimeter across the terminals on your battery when the alternator is running, and that's actually a good way to see if the alternator is charging. It should be around 14.5 volts. And if your alternator is not putting out, close to that, then your alternator's not doing what it's supposed to be doing. Okay, so out of the alternator to your positive terminal on the battery. And then there's a wire that usually comes down, and most vehicles have a heavy wire from the positive terminal on the battery to the starter. And that has to be about a number 4 wire, depends on the application, sometimes as big as a number 2. And it could be larger than that, but either a 4 or 2 is usually about what people use. But this explanation isn't about what size wires you should use, it's about the system itself. So I'm just throwing that in as a little bit of an extra. Okay, so from the positive on the battery, you'll also have a feed to the key switch. Okay, so this is important in this explanation because we're going to talk about something. I've got a little light here. Okay, this is a 12-volt light. And, when everyone has seen this, you go to start your vehicle, you turn your key to the run position, and all the lights, the warning lights on your dash will illuminate. Okay, and that's normal because, that's a test to see if they're working. Okay. And then once you start the vehicle, there's a slight pause, and then usually they all go off. And then if you don't have any lights on the dash, good, everything's running fine. And most alternators have a similar device in the wiring. There's a light that comes on the dash. It'll either read battery, or it'll read alternator, or it'll be a little symbol of a battery. That'll light up when you go to start the vehicle. And if everything's running good and the alternator's working like it should, that light will go out. Now, if you're driving down the highway someday and all of a sudden that light comes on, and some of you have experienced this, you'll get that little battery symbol that lights up, or you'll get the alternator, whatever the light says, that'll illuminate. And you'll think, okay, what's wrong? So what's happening is the voltage in your system has dropped below a critical level. And the alternator is either not putting out, the battery's defective, or some of the wiring can be defective in between. But usually it's the alternator or the battery. This is the problem, and very often the alternator. That light has become known, in mechanic circles over the years as an idiot light, because it really doesn't do anything other than it illuminates when there's a problem in the system. Okay, it shows up for a second when you go to start the vehicle. It goes away the minute the alternator starts to charge. It only shows back in operation if there's a problem in the system. So they call it an idiot light. So from your key switch, from the run position of your key switch, okay, and we're getting to those terminals on the alternator. There's these other 2 terminals. You got your output terminal here, but you've also got your excitation current, okay? You got a wire that comes from the run position on your key switch to the alternator, and that provides voltage to excite the stator, and so it generates power. And so what happens, this is where that light is. It's right in this wire here. Okay, now what happens, I've put in, there's the idiot light. Okay, so here's the idiot light. All right, now what happens when you put the key to the run position? The engine's not running, so this is not turning. This is not generating power yet. You put your key to the run position, 12 volts DC, flows down here, and it'll go through this 12-volt light, and it goes here to ground inside of the alternator. And that lights up. There's a difference in voltage between the run position on the key switch and the alternator. So there's basically nothing happening here, and there's 12 volts over here. So you need that to run the bulb. So the idiot light comes on for a second when you hit the run position. When you start the car, the alternator kicks in, current runs through here, through the light, in here, and it provides excitation current to the field in the rotor, okay? And then the minute that starts turning, and there's excitation to it, it's going to generate power. And what's happening is that power is all of a sudden going to start coming back through that line. And what is it? It's 12 or 14 volts DC. Let's just say, for argument's sake, it's 12 volts DC coming out of there. And this is 12 volts DC, right? Coming out of here. So what happens in that instant, is there's 12 volts coming from either side, and what they do is they just cancel each other out, and the light goes out. Okay? So you're driving along an hour later, and all of a sudden, the alternator, something happens internally, whatever, it's the voltage regulator or something goes wrong inside the alternator, and it stops generating power. Then what happens is this voltage that it's feeding out drops to nothing, or drops to less than 12, and you have a difference in potential across the light, and that light will light up again. That's this top one here, excitation wire that goes to the voltage regulator. The other one is a voltage sensing wire, and that's the one that reads the voltage in the system to tell the voltage regulator how much excitation current to put into the field, so it'll generate more power or less power. So this is a voltage sensing wire. It comes out here, and what often you'll see is they'll connect this wire right to here, and it just senses pretty much the voltage coming out of the alternator. So it's pretty close. What they actually recommend is you take this voltage sensing wire and run it quite a ways away from the alternator, usually to the lug on the starter, and that's quite a ways away, and that'll give you a better representation of what voltage is actually happening in the system. Now, it doesn't make a hill of beans a difference very often, but if you want to do it right, if you're going to wire your own thing, very often they say to take it from here instead of just putting it to that lug, because you'll often see that. You'll see it'll go from here to that lug. That's what they do, right? But they say to take it farther away, and you'll get a more accurate reading of what's actually happening in the system. Anyway, thanks for watching. Comment, like, and subscribe, and we'll see you again here very soon on Everyday Projects. Bye for now. And leave a comment down below. Give us a thumbs up if you like this kind of content and you want to see more. Just subscribe. And I'm here every week with a video of some sort. All the best. Take care. We'll see you again here on Everyday Projects. Bye for now.